Hi, welcome to the Rancher Fleet for Management, Deployment, and Visibility into the Edge talk at the ARM DevSummit 2020. I am Mark Abrams. I'm a field engineer with Rancher Labs, field engineer and edge specialist with Rancher Labs. And I'm excited to share this fleet demo with you, this fleet presentation. For the first things first, I want to give an overview of fleet, and then we'll kind of jump into the details. So first of all, why fleet, right? Why do we want to use fleet management? I think it's obvious for most, but I don't want to leave things unspoken. We need solutions like fleet to help manage hundreds of thousands of Kubernetes clusters, and that's what's happening with computing, especially at the edge. While fleet is designed for massive scale, it can also be used for less than 10 clusters at a time. So this is a viable way to do GitOps even in the data center. And fleet really is GitOps at scale. So let's talk about some of just general concepts. Using standard Kubernetes controllers, the fleet manager and fleet agents work in concert to basically deploy and manage your software. While the system is designed for edge scale, as I said, it is possible to do this in just a single cluster. With multiple downstream clusters, the manager is intended to run in a cluster of its own, and then each cluster will run a fleet agent, which is how they receive workloads and modifications of those workloads. And I'll get into kind of the details of that communication channel shortly. In addition to the manager and the agent, we have, in addition to the controllers, we are using a set of custom resource definitions in Fleet. And custom resource definitions are just a part of Kubernetes. It's a way for us to create custom resources. Everything in Kubernetes is resources. We can create custom resources. So this is really just using Kubernetes as it was designed to be used to do some additional work, which includes managing multiple large-scale clusters. I want to say at this point also that Fleet is a very new project in the Rancher Labs portfolio. We've been working on Fleet for some time, and by the time that this presentation airs, it will be also live from Rancher Labs. We'll have a generally available version of it. However, I've been in close contact with the developers, and some of the terminology may change, and even some of the sort of how it works may change. So please, and I'll give you links at the end, but please hear me throughout, but then go check out our repository and docs and see what's changed and see what's new when this airs live. So back to the Fleet concept. So the GitOps CRD is basically, the Git repo is basically a way for connecting with Git repositories, right? And so it's just a custom resource definition that knows about a Git repository where it's going to pull from. The bundle CRD is the fundamental deployment unit used by Fleet. And the bundle actually contains Kubernetes configurations in various forms, and we'll talk about those shortly. And then when you apply the bundle, when you basically build the bundle, when you the bundle deployment CRD is what really manages the state of those configurations for specific clusters. So when you have thousands or tens of thousands of clusters or devices at the edge and you're managing them through a fleet manager, you need something to represent what state those things are supposed to be in. And if you don't know, Kubernetes is declarative. So we can declare what we want the state to be, and then Kubernetes will help us make it so. So obviously bundles are a critical component of this fleet management. So let's try and understand better what bundles are. So bundles are simply a collection of resources that include additional deployment specific information and can be deployed to multiple clusters. I think I said that before. The bundles can get large, especially with large number of clusters, right? So a bundle encapsulates all of the things that you want to send out to all these devices. Now, a bundle would be created only for groups of components that go out to the same cluster. So you may have multiple bundles with devices within those bundles that have different sets of resources that are getting updated. So you'll certainly have lots of devices, but one bundle doesn't necessarily cover all the devices in your fleet, but it can, but it doesn't have to. And then the other thing about bundles is there's a command line tool which can help improve the user experience and other parts of the experience as well. I'll talk about that in a little bit. And then, GitOps is possible since the bundle is really represented by that Git repository and by single files on disk. So we can take the diff of the change sets that you want to send out to your applications and to your clusters, and then apply those in a Git diff fashion. So this means we can source control our changes and basically affect change in the cluster when the source control changes. And that's why we have that Git repo CRD, because the Git repo then looks back at the actual Git repository, looks for, hey, it changed, and now let me apply those changes to all my downstream clusters. The bundle strategy is really intended to try and be as Kubernetes friendly as possible. And the way that people are using Kubernetes today is through standard Kubernetes configuration files, Kubernetes YAML, or through Helm charts, which are essentially an application, a package manager for Kubernetes resources, and through Customize, which allows me to create those first two types, but then to change configuration through properties files and other config files. Since bundles use standards Kubernetes configuration models, you can really choose the one that suits your experience best. So if you know Helm and you want to use it, great. If you know Kubernetes YAML, use that. Let's look at how the bundle resource gets created from the configurations. So a bundle has three types of resources in it. As I just said, these are the Kubernetes manifests, the Helm chart, and the Customize configurations. We can prepare the resources to be pushed to the target clusters, and there's actually the target clusters pull this, so it's actually a pull mechanism. Target cluster is going to be notified. It's going to check in with the manager and be notified that there is a change set, and then it'll pull that change set. The fleet never pushes stuff down, actually. And it does this by rendering this bundle. So this can be automated or done through the command line, as I said before. Each one of these directories and content types are optional. So you can just do Kubernetes manifests or just do Helm charts. We'll make the pipeline happen regardless. And since each content type is optional, regardless of what how you work, we can make it work with Fleet. So if you prefer Helm, use Helm. If you prefer Kubernetes manifests, use those. So there are three phases, right? I showed you that previous diagram. There are three phases. The first phase is the plain Kubernetes YAML, which is prepared. So we prepare the Kubernetes YAML to be part of the Helm chart. Then in phase two, we take the content from the manifest directory in the Helm chart, from the chart templates, which is where they would be in the Helm chart. And then we can compile the Helm chart. And you don't need to know anything about Helm charts to do that. And then in phase three, we'll apply those customizations. So if you want to add different properties for different things, you can do that. It gets deeper than that because we can do that at the cluster level as well. And I'll explain that in a moment. So to customize downstream clusters and groups and cluster groups, for multi-cluster use cases, there's this file called the fleet.yaml configuration. And that's really what's housing the bundle. And we can target specific clusters with specific customizations this way. So you get all of those previous ways to configure your software. And then in addition, we can add some changes that will allow us for cluster specific. So if you have a single node cluster or multi-node cluster, you can modify those clusters individually. And an example of that might be geolocation or something, depending on the location, almost what we do with locales today on any given computer, only of course it's systemic, right? It's not necessarily human readable or recognizable, but it's systemic to the location or the use case or something like that. You can change things like namespaces in the fleet.yaml. I'm not sure why you would change the namespaces, but you can, and I'm sure there's a good reason to do it. I'm sorry, you can change the default render pipeline configuration directories. I'm not sure why you would do that. Namespaces, you can set a default. You actually need a default to deploy your Helm charts into. If your Helm charts don't have one, this one will be used. This is not a replacement for RBAC. So you still need to do, if you want higher level security, you still need to do role-based access control through the Kubernetes mechanisms. We can set rollout strategies. So we set rollout strategies. We can create partitions like which are basically groups of clusters, or we can do it based on the cluster or partition availability. And this is really, we can do things like canary deployments. So if I want to test a change in a group of 1,000 clusters, I could create a rollout strategy that allows me to target only 100 of those 1,000 clusters, allowing me to do a 10% rollout, then monitor that change over the course of, say, a week or 10 days or whatever's necessary, and see how it goes. And then if I like it, go ahead and roll it out to the rest of the clusters. I can also target clusters based on selectors. That's just Kubernetes selectors, pretty standard. And I can apply overlays to my targets, which is nice. So the overlays are another way to modify what's in the downstream cluster, or what's being changed for that downstream cluster. So here's actually a snippet. I thought maybe a little example would be helpful. Here's a snippet of a fleet.yaml, and down towards the bottom of this is just the target section. There's a lot more. I recommend you go look at the docs for the full content manifest, but basically at the bottom of this, you'll see there's this cluster selector. And but what you don't see is that there below that even, and this is all I could fit on the screen, there's a cluster group selector and cluster groups. So that allows me to create different types of targets for this change set, right? So this is a nice way to sort of monitor, manage, handle a fleet, and just impact the parts of the fleet that you want to impact in terms of application changes. Even systemic changes can be done through Kubernetes. As far as target matching goes, all clusters and all groups in the same namespace as the bundles get evaluated against these bundle targets, right? All criteria here is additive. So it's cluster selector and cluster group selector and cluster group that are evaluated for what is the change set that should be applied to the clusters. Here's a picture, here's an image of resource overlays and how you might do patching. So you can see in this, the target reference has a series of overlays. That's at the bottom of this screenshot. At the top, you see the manifests. So the manifests are part of that core part of the bundle. And this is the file-based system that we can do the diffs on, right? Well, what happens here is that the overlays custom at the very bottom, that deployment underscore patch.yaml is going to be the patch for the manifest deployment option here. So a file named foo is going to replace a file named foo from the base resources, right? So that's what you would expect. The distinction here is that I've got the underscore patch. So deployment underscore patch or foo underscore patch is going to replace the foo.yaml, deployment.yaml in this example in the bullets. Patches can be applied or will be applied using JSON merge, strategic merge patch, or JSON patch. This also works with YAML syntax, so it's not something to worry about. And it's really kind of the backend methodology for how the patches are done, and just it's not really something you have to worry about, but many people want to know. Maybe you can optimize those patches over time. Okay, so that's kind of the talk about bundles and how bundles affect the clusters and the fleet of clusters. Let's look closer at the actual architecture of this system. So the names here might change, but I believe the sort of structure of this is really going to stay consistent. It has for months now been very consistent. So we have access from all of the sort of relevant points in Kubernetes. And so with Kubernetes, we use kubectl, or we use the Kubernetes API with custom resources, or we do some sort of like GitOps or other interaction with the APIs, right? Some other system is talking to the APIs. All of that still applies with Fleet. The clusters then pull down the desired state. What they do push is their status. So you can see in this image down towards the bottom, on my bottom right, the cluster group says ready in sync, but the middle one says out of sync modified. So that cluster group that's modified needs a change. The cluster group that's in sync is set and doesn't need to pull down any bundle any deployment bundles. So it's good to go. So early on, I mentioned the manager and the fleet manager and the cluster agent, right? And the way they function together is that the manager pulls its bundles from the Git repository, and the agent pulls the specifics as a bundle deployment from the manager. This means that managed clusters can run in private networks and behind NATs. The only requirement is the cluster agent needs to be able to communicate with the Kubernetes API of the cluster running the fleet manager. So there does have to be some communication to your fleet manager in order for this to work, but it's purely through the Kubernetes API, which is really a single open port, which you know, in most enterprises, that's acceptable. Though there is an exception to this, and if you want to use manager-initiated cluster registration flow, then this would change. So on the one hand, I take my cluster and I point it at the fleet manager, and I say I want to be a managed cluster, and the agent reaches out. And in that scenario, the agent will have some sort of a cluster token, and it reaches out. The other way is to say from my manager, tell that cluster you are going to be managed. And the flow is a little bit different. And the networking, of course, around that is going to be a little bit different as well, because then the manager does need access to that cluster. Cluster agents are not assumed to have this always-on connection, and that's critical part of Fleet that we've noticed for pretty much every customer and prospects that we talk to. The edge is full of devices that disconnect. And so we knew that was a critical requirement to the fleet manager. The agents shouldn't be noisy. If they can't connect fine, handle it. The fleet manager shouldn't be concerned. Over time, I expect that there will be enhancements to come in this area where we may want to add some intelligence around, well, when should I get concerned that I haven't heard from the fleet, from the cluster or from a device, in how much time is it acceptable for? Maybe it's never. But right now, it's just a trivial, like, don't worry about it. It'll come back when it comes back. And then in terms of security, we addressed a little bit of security around the NAT and the private networks, and accessing the manager just only through the Kubernetes API, only in this pull model where the agents reach out. In addition to working with those sort of network security policies, we're addressing security with tokens and service accounts. So clusters are registered by optionally these registration tokens, which can optionally expire. And then the cluster registration token is only used during the registration process to generate a credential specific to that cluster. The fleet manager then uses that credential to basically establish, some things that it can do with that fleet. So the service account given to the clusters only have privileges to basically list bundle deployment in the namespace created specifically for that cluster. So if you're familiar with Kubernetes, this is a nice way to basically say, okay, you can look at this one thing, but don't look at anything else in this cluster, Mr. Manager. So in addition, the service accounts can update the statuses for the sub-resource of these bundle deployments. So in the bundle deployment, there's a resource status. And remember, I showed you that there was one that needed updating and one that was online and ready. Those are the status types that I'm talking about. Now, finally, scalability. I said fleet is designed to run tens of thousands, hundreds of thousands of clusters. We're designing it to scale up to 1 million clusters. I don't have details on how this works today. Details just weren't available at the time of the presentation. I know this is a big one, and unfortunately, I don't have any more information on this. So I ask that you follow the project and reach out to me or to through our Slack channels to get more details as this develops. Personally, and I work with customers and prospects day in and day out as a field engineer. That's pretty much my job is working with people who are in this space trying to solve these problems. I have talked to customers that have use cases for tens of thousands of clusters, but no one yet in the hundreds of thousands or 1 million clusters. If that's a use case you have, please reach out to me. We'd love to hear your story. We'd love to make sure that we're meeting that use case, that our requirements actually meet your requirements, and that we're on the right track for that. All right, I'll give you a quick command line overview. We really only have one slide for this. The command line, as I said, is kind of gives the ability for human interaction. Because this is exposed, because Fleet is exposed as a pure Kubernetes API using the controllers and custom resources, I can just access that API through this tool called Fleet, which is a command line tool, and do things like fleet apply, fleet test, fleet install. There are two places where this can be useful. One is in a dev test scenario. I just wrote my bundle. Before I commit it to the Git repository that's production, I want to test that it's going to operate properly. So maybe I want to run this at the command line. The other is if you're using an existing GitOps tool, then you may find that this is these commands would get integrated into that existing tool. Let's talk about GitOps, speaking of that. So One method is GitOps. Another method is CI/CD. These are two methods for deploying your software. GitOps is more recent and sort of can encapsulate some of the continuous integration and continuous delivery, or sometimes CD is continuous deployment. Those are two different things, but it's not clear which one you're doing until I talk to you. So for GitOps and CI/CD, the GitOps patterns that we see, because Fleet is, again, this standard Kubernetes API, it's going to integrate into existing ecosystem for GitOps. If you use Fleet with the Git repo CRD, then we're going to manage the resources directly in the Fleet controller itself. The other option would be to define some sort of a GitOps pipeline that runs in a cluster. So when you do GitOps without Fleet, the tool you use is basically going to point directly to your clusters and do its applies in those clusters. This would be tools like Argo CD or Flux. So that's one of the ways that you can do it. And then of course the other one is to use the GitOps method, or I'm sorry, the Fleet method to manage your Git repositories. For traditional continuous integration, you can run Fleet test and Fleet apply as part of that CI process, right? So there's another mechanism where you just integrate it into, if you're using Jenkins or Bamboo or something along those lines. So in terms of project resources, the Fleet project is open source. The resources and information from this presentation can be found at GitHub, github.com/rancher/fleet. There's also a community on Slack. There is a specific channel for Fleet on Slack that you can use. And so I encourage you, and we would love to get your feedback and hear from you in the Slack channel. We would love to get your pull requests and your feedback on the GitHub channel. And that's it for the Fleet management presentation. And thank you very much. And I hope you have a great ARM Dev Summit this year.